Today we are going to continue our fibers. We are following this list again. So we are done with all the cellulosic manufactured fibers. So today we're going to talk about synthetic fibers. And I am specifically going to talk about nylon, polyester, acrylic, modacrylic, and olefin in this class. These are all petroleum-based products, and they have similar properties because they are made out of the same type of raw material. So the common properties are: one, heat sensitivity. All of these fibers are heat sensitive. They can melt if you use too much heat. Also, if you are trying to iron them, even if your temperature is not too high, sometimes it flattens the fibers, because even though they don't melt completely, they just get soft and then they get flat, and that causes shine on the surface of the fabric, and that's called glazing. This happens when you have formal pants, for example. Sometimes some of those, when you iron them, you will get a lot of shine on them. And that's why that happens, because those fibers can melt with high temperatures, but if you're close to the melting temperature, it still gets soft, and you can flatten them and it will make them stay flat after you iron them. So that causes this extra glazing. They also have a pilling property. Most of these fibers do pill. The reason is because these fibers are stronger than natural fibers, so they don't easily break. So when they roll up on the surface of the fabric, they don't break, they just stay there. If the fibers are weaker, they break and they don't cause pilling. But all of the synthetic fibers are strong fibers. They don't break easily. They're also long. Most of the time they're filaments. So pilling is a problem. They also have a static problem. They do get static electricity because they're hydrophobic and they don't like water. They don't absorb water. That makes them hold up all the electricity and it causes static. So if you wear, for example, nylon or polyester pantyhose, you will sometimes feel like they're just sticking to your skirt or to your pants, and it makes you feel uncomfortable. So that's one of the properties of synthetics. They are also oleophilic because they are oil-based. They come from petroleum byproducts. So they love oil. They get stained by oil. If you spill anything with oil on them, they will get stained. The manufacturing process is similar to what I have explained in the fiber manufacturing processes. Most of these that are heat sensitive are produced by melt spinning, because they melt, they can be turned into a solution by heating them up, and then you just draw the fibers out with the extrusion process through the spinneret, and you have to cool them down. One other property of these fibers is that you can do heat setting, and heat setting is this. Basically, when you are ironing a fabric and you're not as high as their melting temperature, there's a temperature called the glass transition temperature. So that is the temperature where the fibers get soft, and you can shape them to whatever shape you want at that temperature, as long as you don't melt them, as long as you're not as hot to melt them. But you can shape them into any shape, and then when you cool them off, they stay in that shape. This is called heat setting. So it stabilizes the fibers, and you can put permanent pleats on a fabric, for example, if you can go to that glass transition temperature where you can change and transform the shape of a fiber. How do you identify synthetics? There are a couple things you can do. One thing that's very easy to do is the burn test. If you burn it, if it melts, it's a synthetic fiber. You can also look at it under the microscope, but that's not going to tell you a whole lot, because these type of fibers can be modified. The shape can be modified, the cross-section can be modified. So you can't really tell a whole lot with the microscopic appearance, The only thing you can probably tell is if something is not cotton or not wool because of the shape of the fiber. If it is very smooth and round, you know, you can usually tell that it's a synthetic, but you can't tell which one. You can also do solubility tests because some of those fibers are soluble in certain chemicals. We talked about fiber modifications already, but I'm going to just summarize this a little bit. So with these fibers, you can change the cross section, you can change fiber diameter. It all depends on the holes on the spinneret. If you make hollow fibers, those are really good for thermal properties. They are insulating, they help you keep warm, they're lightweight because they're hollow. Trilobal, pentalobal, multilobal cross section usually helps with hiding dirt and dust. Those are also good for apparel and carpeting. Voided fibers, they also help hide soil in carpet. Flat ribbon fibers, those are a little more luxurious looking. They're good for formal wear or special occasion apparel. And then you can get channel fibers. Those are great for activewear because that improves wicking, because there are all these channels, the water can be transferred easily. You can also modify the fiber size or diameter to create microfibers. You can make low pilling fibers by reducing the molecular weight. Reducing the molecular weight is going to make the fibers a little bit weaker, not as strong. That helps the fibers break up and reduces pilling. You can reduce the abrasion resistance. That also helps with reducing pilling because it just makes those short fibers to get off the surface. We do that with apparel furnishings and others. High tenacity fibers can be created by doing some fiber modifications. So basically what you do is when the fibers are coming out of the spinneret, you're pulling them with some tension, which is called drawing or stretching. And that helps all the molecular chains to become more parallel. And that makes the fibers more crystalline. And that creates very, very strong fibers. So we do that for ropes, for airbags, for parachute cords, those type of fabrics that require a lot of strength, tensile strength, to protect the people who are wearing them. You know, those are the areas where we need high tenacity fibers. You can also create low elongation fibers. If you don't want those fibers to be too elastic or easily elongate, and a lot of those synthetic fibers are like that. So if you think of nylon, polyester, just think about plastic bags that are made out of nylon or polyester. You know, those things have too much stretch, and sometimes you don't want that much stretch. You want to have lower elongation, and you can do that by modifying your fibers. And one of the ways to do that is you blend it with cellulosic fibers that don't have too much elongation, and that will also help. All right, so we're going to start with our first fiber. This is nylon. Nylon is one of the first fibers that was invented as a synthetic fiber. And the raw material for nylon looks like this. Those are polymer flakes, and you melt those, go through melt spinning, draw the fibers, cool them off, wind them on a bobbin, and you have nylon yarns. And then you can use that to make fabrics. Nylons are made out of polyamides. Remember this. These are amide groups. They have carbon, oxygen, nitrogen, and hydrogen in them. And as I mentioned, it was the first commercially available synthetic fiber. And actually, the invention of nylon changed the fashion industry altogether, because until nylon, people were using cotton, wool, linen, socks, and women were wearing longer skirts. And nylon actually started to be used for pantyhose. And when it was so comfortable and elastic, you can wear it. easily, it changed fashion because mini skirts became fashion after the invention of nylon. It also dominated the carpet industry and activewear industry later on. Nylon fibers are melt spun, so they're very easy to engineer because melt spinning allows you to change the fiber size, fiber diameter, cross section. A lot of things are easier to modify with melt spinning. This is what it looks like under the microscope. Those are some round cross section. So this is the longitudinal view. They are round, so they have a lot of luster. This is the cross section of nylon fibers, but you can produce them in any cross section. So you can make them trilobal like this with 3 lobes. And if you notice on the trilobal one, you see that the dirt and soil usually hides in these areas. So on the outside surface of the fabric, you don't really notice that. So those are really good for carpets. These are different types of cross sections you can get with nylon. Tactile is a registered trademark that is made out of nylon, and it is just modified for different end users. So you can see this is a dog bone cross section. You can have all these different types of cross sections together. There's a lot you can do with the modifications. This is a hollow cross section. This is good for insulation, but it also makes the fibers lightweight. So those are good for making maybe lightweight blankets, for example. Physically, nylon is very lustrous inherently. So you have to add delusterants into the solution before you make nylon fibers to get rid of some of that. You can make them super fine microfiber size, or you can make other fiber diameters. We can dye nylon with acid dyes and dispersed dyes. We'll talk about dyes at the end of our semester when we get into printing and dyeing. But sometimes we also solution dye, which means you add pigments to the solution, color pigments to the solution before you make the fibers. That way the color is more uniform in the fiber because it's a hydrophobic fiber, so it doesn't accept dyes and liquids. It doesn't absorb them easily, so solution dyeing is a good option. The drape of nylon varies. If you have microfibers, those drape better. The covering power can be changed as well. You can produce them at different levels of opacity. They are usually wrinkle-free, and this is true for polyester as well. This is true for a lot of synthetic fibers. They do not wrinkle much. They have excellent resiliency, and especially if they are heat set, they do not change their shape in room temperature. Unless you go to very high temperatures, you cannot really wrinkle them. So you can bunch them up if you like, and it will just go back to its original shape. It has excellent resiliency. Compression resiliency is the same way. That's why we use nylon in carpets, because people are walking on them, you're crushing them constantly, but you can't flatten them because they have good compressional resilience. They just bounce right back. These are carpets made out of nylon. They have good dimensional stability. Again, if they're heat set, they're not going to change their dimensions. They'll always stay in that shape, in that size. They have excellent elastic recovery. When you elongate those, they elongate, but they also return back to their original length. That's why they are perfect for pantyhose. They're hydrophobic. They do not absorb water much. So they're very uncomfortable in hot and humid conditions. If you make nylon garments, you have to either make them loose or you have to use staple fibers. So you cut all the filaments into staples, or you blend them with something, because otherwise they're not as comfortable. So you can make them comfortable by blending them with other things, but naturally speaking, because they are hydrophobic, they are going to make you feel so wet and clammy. The good thing is nylon fibers dry so easily because they don't absorb any moisture. They don't absorb moisture, they don't absorb water. So when they're wet, they can dry very fast. If you weave them tightly, you can produce wind-resistant fabrics. It won't have any permeability of air, or it will have minimal air permeability. The stretch and recovery is great because we mentioned it has good elasticity. We did mention these are hydrophobic. They don't absorb any moisture, so they have a lot of static buildup. Their strength is great. You can make high tenacity nylon fibers. They are even greater in strength. And we use those for seat belts where strength is very important. They also have excellent resistance to abrasion. And I told you before, the tensile strength and abrasion resistance are related. If a fiber is very strong, they usually have good abrasion resistance as well. And because they're hydrophobic and they don't absorb a lot of water or moisture, they can be used in items like luggages. They can be damaged if you expose them to sunlight for a long time, but you can also chemically modify the fiber to make it more resistant to sunlight. So there are things you can do, but inherently they will get damaged with prolonged exposure to sunlight unless some modification is done. They are also resistant to rotting. So any fiber that is hydrophobic is going to be more resistant to rotting. If you put them in moldy environments or in the rain or outdoors, they're not going to rot because they are hydrophobic. They don't absorb any of that moisture. They don't get affected by mildew. And this is true for all other thermoplastic fibers like polyester, acrylic, and so on. It's easy to care for. So when you wash it and clean it, nothing happens to them. It's very easy. As long as you don't use super hot temperatures, they can be washed, they can be dry cleaned. They can withstand a lot of agitation in the washing machine. You can use detergents with them. Sometimes nylon can be damaged by stain removal compounds and some of the dry cleaning solvents, so you have to be very careful. And also you have to be careful with the temperature settings because they are thermoplastic. You don't want them to melt, or you don't want them to change their shape by going too close to their melting temperature. Excessive bleach will weaken the fibers. So nylon is great for swimwears because, one, they dry so quickly when they're wet. So if you swim and you get out, it will be faster for a nylon swimwear to dry than, say, something made out of cotton, obviously. But when you are swimming in the pool, there's a lot of chlorine in there. If you don't wash your swimsuit every time you get out, and that chlorine stays in there, that will weaken the fibers and that will damage your swimsuit. Nylon, this is specific to nylon. This is a very unique characteristic of nylon. It gets easily stained in the wash water with dyes from other garments as well. So for example, you have a white nylon shirt, you put it in your washing machine with some red socks, and somehow the red socks are releasing some of their color in the washing machine, and that makes the color of the wash water a little bit darker. That will make your white nylon shirt almost pink when you take it out. So it gets easily stained by the dirty water, by the wash water in the washing machine, if there's a garment that is releasing dyes in the washing machine. So that's something unique to nylon. You have to iron them at low temperature, but storage is not a problem. You can store them anywhere. It won't affect because they are resistant to mildew, rotting, and so on. We use them in carpets, lingerie, hosiery, socks, active sportswear, windbreakers, parkas, and in industrial applications, nylon is used in our tires, seat belts, car interiors, upholstery, They're used in parachute fabrics, ropes, cordage, conveyor belts, fishing lines, fishing nets, umbrellas, paint brushes, luggages, camera bags, horse blankets, backpacks, tents, sleeping bags. I mean, there are so many uses of nylon other than apparel. Now, our second fiber is polyester. Polyester is a manufactured fiber, but remember, nylon is made out of polyamides. Polyester is made out of esters. So it is 85% ester. You have to buy them in pallets and you have to melt them and then extrude them through the spinner to make the fibers. So they're usually melt spun. Polyester is one of the most versatile fibers. The reason for that is because you can blend it with anything. You can blend polyester with cotton, you can blend it with wool, you can blend it with anything, you can modify them. It's a very versatile fiber. We use them in apparel, we use them in home furnishings, so it has a lot of different uses. Again, you can't tell the polyester from nylon because they're fiber shape, fiber cross section, they can look very similar because these are all based on the spinneret. You can make microfibers out of them, so there's not a whole lot of difference with nylon. This is a polyester tow produced with PET pellets. We call it PET because the technical name for polyester is polyethylene terephthalate. So you can get polyester in filament form. As you can see, there are no short fibers, these are long fibers, but you can then cut them into staples if you are going to blend them with another natural fiber. Physically, very similar to nylon, inherently lustrous, so you have to add the lustrants. You can dye them with dispersed dyes. You can dye them by solution dyeing. The drape can be varied, the opacity can be changed. We can make sheer curtains with polyester. We can also make more opaque materials. They are wrinkle resistant. They don't wrinkle. Like I said, nylon, polyester, those fibers don't wrinkle. They have excellent resiliency. They are susceptible to pilling because, again, they are synthetic fibers. Most of those fibers are strong fibers, so they do pill. They have good dimensional stability if they're heat set. So again, this is also same as nylon. Their shape retention is good. They're hydrophobic. They absorb little water. They're not comfortable in hot temperatures. They dry easily. So all of these are very similar to nylon. You can make them insulative. You can bulk the fibers. You can texturize the fibers to create some crimp and more bulky, more insulating type of fabrics. You can use them for fiber fill or bedding. They have good stretch and recovery. Their elasticity is good. Their elastic recovery is good. They have a little low recovery at high elongation compared to nylon. So they're not used as much for pantyhose. Because nylon, when you elongate it, it has great recovery. It goes back to its original length. So polyester is not as great. And that's why we use nylon for pantyhose and not polyester. They're hydrophobic, so they do cause static. Again, same as nylon. They're blended with rayon, cotton, and other fibers. And when we do that, those fibers get the strength from polyester and the natural properties from the natural fibers, and you can get some really good materials at the end. So blending a natural fiber with polyester is helpful because natural fibers are not as strong. Polyester is very strong. So it makes the fibers or the fabrics more durable, but at the same time, you get some of the good hydrophilic properties from cotton, for example, and so on. They have excellent resistance to abrasion, like nylon. They have good resistance to exposure to light. So polyester is used a lot for outdoor applications. Now they're also resistant to rotting, like other thermoplastic fibers. They're easy to clean, easy to wash, easy to dry clean. Chlorine bleach can be used It's not damaged so easily by stain removal compounds or dry cleaning solvents. You have to iron them at low temperatures because they're thermoplastic. You don't have to worry about storing them in special environments. They're resistant to rotting, mildew. So one thing you should remember about polyester that's different from nylon is nylon is more suitable for pantyhose and stuff like that because of the high elastic recovery compared to polyester. Even though polyester has great elasticity, nylon kind of surpasses that. And also polyester is very versatile. It can be blended with so many other fibers very easily. You can use polyester to create silk-like fabrics as well. You can bulk them to make it look like wool. So this is why I call it versatile. You can make it more silk-like, you can make it more wool-like, you can make it more cotton-like or linen-like. Coolmax is a registered trademark of polyester, a knit fabric. These are high-performance fabrics engineered to make your sweat move away from your body so that you feel comfortable, especially for activewear products. Coolmax is used a lot because polyester is hydrophobic, but when you have this special Coolmax polyester be transported away from your body and that moisture or the sweat is transferred to the outside, it dries easily, it makes you feel more comfortable. So that's good for activewear products. Okay, now before I get to all of it, I'm going to go to iTextiles really quick and show you a couple pictures. These are nylon fibers, round cross section. This is a different trilobal cross section. Hollow, we talked about these. This is a swimsuit made out of nylon. It's 80% Antron nylon. This is a registered trademark. And it has 20% spandex for more elasticity. And this is the close-up view. These are nylon fishnet hosiery. Carpet, I think I showed you this one. This is a Velox blanket. So this fabric has a polyurethane foam base, and you have small nylon fibers that are glued on the surface to create this blanket. Polyester, these are trilobal cross sections of polyester you can get. Triexta is one of those fibers. So it's a generic name of a subclass of polyester that has stain resistance to common food and beverage stains, and it's stronger than regular polyester. Another variation of polyester is Elastoral P. This one is an inherently elastic type of polyester to increase the elasticity of polyester. This is an example of heat setting. So this is a jacket. You see one side of the jacket, and you can see that collar is pleated and then heat set. So once it is heat set at the temperature that is warm enough to be close to the glass transition temperature, then when it's cooled in room temperature, this pleat will never go away. Unless you iron this with a temperature that is probably around the glass transition temperature of this polyester, you're never going to flatten this. It will always stay like this. The pleats will never come off. This is a dress made with polyester fabric. This furniture is made out of polyester fabric, and this is a magnified view of that. And this is a hospital cubicle curtain. This is the magnified view. Those are made out of polyester, and you can manufacture them with certain modifications to make them flame resistant, because hospital curtains have to be flame resistant. So this is one of those. You can recycle polyester, and you can create fabrics out of recycled polyester. So this is a indoor-outdoor carpet that is manufactured by recycling plastic bottles. Now, because these fibers are oleophilic, all synthetic fibers are oleophilic, they will get stained by oil very easily. So you should remember that oil will stain polyester. About recycling, what you need to do is, for example, if you have PET bottles, you clean them, then you chip them like this. You can make them into fibers again. So polyester bottles, your water bottles, they all can be recycled and turned into fabrics. This is the recycling process. So all the waste, plastic waste, polyester waste is collected. They're granulated first. The decolorization is done. You get the raw material, you turn them into pellets, and then the pellets are used then for melt spinning, and then you get polyester fibers. All right, so that was that. So we're gonna go back to our synthetic fibers. I have two more to discuss. One is olefin, and olefin is a very interesting fiber. We usually solution dye because it's very difficult to dye olefin. So you add color pigments into the solution, so you get those, and then when you extrude them through the spinneret, you actually have colored fibers. It's a crystalline synthetic polymer, and olefin is composed of 85% by weight of ethylene, propylene, or other olefin units. Okay, olefin is resistant to weathering. It's relatively inexpensive. It doesn't need really any ironing. It's resistant to abrasion. It's thermoplastic. But it's also static resistance. It doesn't cause any static compared to other synthetics. It can be lightweight. So olefin has certain properties that are different from nylon and polyester. You can produce them with melt spinning, gel spinning, and so on. So the polypropylene in the olefin fiber is the CH3 units. So you have some CH3 units and some polyethylene units, CH2 units. And then there are the olefins. They have no polar groups, which means they don't absorb moisture. They are hydrophobic. They don't have, a lot of OH groups. They are inherently lustrous. So all of those are similar to nylon and polyester and other synthetics. Usually it's a little bit lighter weight, so it affects the drape. The opacity can be changed. They don't wrinkle much. So they are very similar to nylon and polyester. The difference is olefin fibers have lower crush resistance. So they crush, they can, if you make carpets out of olefin, and I've seen carpets made out of olefin, but they're really, really cheap because when you walk on them a lot, they will crush and they will not come back and bounce back like nylon. So usually when you make carpets out of them, they're not high piles. They're usually either uncut piles or lower pile height because it's easy to crush them and flatten the fabrics. So this is one difference of olefin. They are susceptible to pilling. They have good dimensional stability. They're hydrophobic. So these are all similar to nylon and polyester. The difference is olefin has great wickability. So wicking is a good property of olefin. Even though it is not hydrophilic, it does transfer the moisture across the capillaries, and that makes it suitable for activewear, for undergarments, even baby diapers, because of the wicking properties. So remember this about olefin. A lot of things are similar to nylon and polyester because they're all synthetic, but olefin has good wicking properties, even though it's hydrophobic. So it will be able to transfer some moisture across, and it has lower crush resistance. If you have ever seen Tinselate, Tinselate is a registered trademark, and I have seen it on gloves, usually because olefin is used for insulation, especially for cold weather apparel, for gloves, and the filling inside the gloves is usually made out of olefin. And it will have that Tinselate mark on the fiber content in the label, if you notice. Now, olefin is also different from nylon and polyester because it doesn't have as much static. Because it has wicking, it can take up some moisture. So there's not as bad static buildup with olefin as it is with polyester and nylon. This is an example of Thinsulate. This is the inside of the glove. So you see this filling material for insulation. This is a magnified view that is made out of olefin. The strength can be varied by doing fiber modifications. It has good abrasion resistance. It is damaged by exposure to sunlight, but you can add some UV stabilizers to make it more resistant to sunlight, and it has excellent resistance to rotting. It's generally washed. It withstands agitation in the washing machine. It can be dry cleaned, but again, you have to be careful about the temperature. They're hydrophobic, so they do dry easily. You can use chlorine bleach with them. Stain removal compounds don't damage them, and you can dry clean them easily using different type of dry cleaning solvents. Again, ironing, you have to watch the temperature, but it can be ironed. And storage, it doesn't require any special care for storage. It doesn't rot, it doesn't get moldy. So olefin is great for also pantyhose and swimwear because it dries easily. It is hydrophobic, and it has those good properties. It's also used in underwear, socks, sweaters, glove liners, active sportswear because of its wicking properties. It can be used for wind barrier, cold barrier, layer in an outdoor garment. We use them a lot in furnishings, for carpetings, carpet backings, upholstery, draperies, slip covers. And in industrial applications, we use a lot of olefin. And I'm going to show you some examples of where we use olefin. It would surprise you because there are so many different uses of olefin. We use them in car interiors, floor coverings, upholstery, headliners, sun visors, armrests, doors, and side panels of a car. We use them in boats, coverings on docks and decks, filter fabrics, the cover stock on diapers, laundry bags, banners, ropes, twine. There are so many different uses. So this is a needle punched, non-woven carpet made out of olefin. So it's kind of like fake grass. This is made out of olefin. This is a carpet made out of olefin. Again, this is made out of olefin. We do use them in outdoor furniture like this, so you can make them out of olefin, those cushion fabrics. This partition right here in offices, you may see those. Those are usually made out of olefin. This is the magnified view. The office chair here, and this is the magnified view. Those are made out of olefin. These are olefin sacks. And you can tell the difference between a jute and olefin sack because jute has no luster, and you can see some luster and shine on these olefin sacks. And this is a plastic one. If you've ever seen this sign on buildings that are going through construction, Tyvek, this is a registered trademark of olefin produced by DuPont. And this is used to protect the building from moisture and wind when you're doing construction. So they usually wrap the building up with Tyvek paper that is made out of olefin. I don't know if you can guess what this is, but think about that for a second. This is actually the mailing envelope, and those are made out of olefin as well. This is a protective clothing for chemical protection. It is called Tychem. That is the registered trademark, but it is made out of olefin fibers. These are tape yarns. Those are used to raise the pepper plants And those are all made out of olefin as well. So these are used in greenhouses. This net is also made out of olefin here. Okay, so those were olefin. And then our last fibers are acrylic and modacrylic. So acrylic is made out of acrylonitrile units. So it's at least 85% acrylonitrile. Modacrylic, it's just the amount of acrylonitrile units that makes modacrylic and acrylic different. So modacrylic is usually composed of less than 85%, but at least 35% by weight of acrylonitrile units. We make acrylic by dry spinning, so you can dissolve it in a solvent and then spin the fibers. You can also use wet spinning, so you can dissolve it inside some kind of chemical bath. These are the acrylic fibers. So because it's dry spun or it's wet spun, the fiber shape cannot be controlled as easily as polyester and nylon fibers or olefin. Acrylic is extensively used to make knit fabrics, sweaters, crochet materials, cardigans, because they are produced sometimes blended with wool fibers, and they resemble wool fibers. They can be modified to resemble wool fibers a lot, so they're a cheaper substitute for wool. So this is an acrylic sweater. This is a nightgown made out of acrylic fibers. We can also make artificial fur out of acrylic. This is a plush fabric made out of acrylic fibers. This is Fire Cyst. This is a trademark made out of modacrylic. It's a canvas made by the company Sunbrella, and they make umbrellas for outdoors and things like that, you know, for outdoor applications. They're water repellent, they're flame retardant, so these are really great fibers made out of modacrylic. This is an upholstery fabric made out of acrylic. This is a doormat. So you can see the doormat here. This is a magnified view. That is also made out of acrylic fibers. This is a hand crocheted blanket made out of acrylic yarns. Now, acrylic is inherently lustrous. You have to add the lustrants, especially if you're going to make it look like wool. You have to make it less lustrous. So we do that with acrylic and modacrylic. You can crimp them so that it resembles wool better, because remember, wool has this waviness, so you can make acrylic fibers wavy like that. Modacrylic is great for wigs, and it's used a lot for imitation fur and wigs because of its hair-like structure. They can be dyed by dispersed dyes, cationic dyes. This is a modacrylic wig. I mean, it does look pretty fake, but until they came up with these really hair-like wigs, modacrylic was one of the main fibers used for making wigs. We can make them in various degrees of opacity. They don't wrinkle. They have good resistance. They are susceptible to pilling. So all of these properties are similar to other synthetics. They have good dimensional stability if they're heat set. They have good shape retention in general. So for example, if you're making wigs out of them and you curl them with the heated curling irons, those curls are going to stay because it's almost like you're heat setting the yarns. They're hydrophobic, they have more low moisture absorption. So of course, you know, when you're blending them with wool, it takes some of the hydrophilicity from wool, so it can make good, nice, comfortable fabrics that way. And because they don't absorb moisture, they're great for outdoor uses. you can make them more insulating by crimping them, and it will make it more like wool, of course, because the crimp, the waviness will trap air. Because they are hydrophobic, they have static buildup, so that will happen. Of course, you know, with wool, you may not get that, but with acrylic that is sold as sweaters, you know, you will get that kind of static buildup. But you can get away with it if you use anti-static finishes on the fabric. So these type of fabrics can be modified to reduce static also. Acrylic fibers are comparatively weak, actually, not as strong as nylon and polyester. But because of the crimp, it kind of compensates for that low strength. Modacrylic is also a weaker fiber. The abrasion resistance is medium. Again, you know, if the fiber doesn't have very good tensile strength, they're weak fibers, then they will have lower abrasion resistance. So it's much lower than the other synthetic fibers. This is one property of acrylic. They have excellent resistance to sunlight. They're great in outdoors. They have excellent resistance to rotting. They can be washed and cleaned. They're not damaged by dry cleaning solvents. So they're really easy to care for. This is one of the things about synthetic fibers. They're not natural, but they're so easy to care for. I mean, you wash them in the laundry, you take them out, you don't have to iron. They don't wrinkle. So these type of things are great if you want, you know, if you care about these properties, if you don't want to maintain, if you just want to take it out of the washing machine and wear it, you know, or the dryer and wear it. You don't have to care about how to store them because they don't get affected by any moths or insects or mildew or rotting. So these are the synthetic fibers that I wanted you guys to know about. I'm going to go to iTextiles really quick. Those fibers are mentioned here. So you can also go through the lecture notes in iTextiles. This is an example of pilling on acrylic. So they do pill. You see these little balls of fibers on the surface. And this is the magnified view. You can see that fiber because, you know, it doesn't fall off the surface. It has this situation. This is a blanket made out of acrylic. Let me see if there's anything. This is artificial turf grass that is made out of olefin. And if you look closely, they're actually made out of tape yarns. And they look like, I mean, this is a magnified view, so they do look like grass there. I talked about Tyvek. Oh, this is a good example. These are sutures. And sutures are the threads, the yarns that doctors use to stitch people up in the during surgery. So those sutures are also made out of fibers, you know, like polypropylene, and this is nylon. And this is a comparison of synthetic fibers. Again, you know, drape, wrinkle resistance, dimensional stability, those are all pretty much the same for all of these synthetics. Shape retention is generally high for most of these fibers, except maybe acrylic a little bit because it's a weaker fiber. Moisture absorbance, again, the only one that has this wicking property is olefin. All the others are hydrophobic. They have very low absorbency. They all have static. Olefin is average because of wicking. It's a little bit better in that sense. The strength can be changed, of course, but generally not too different, except acrylic is not as strong. And abrasion resistance, acrylic is not as strong. So this is a good comparison of all the synthetic fibers in one place. Okay, I'm going to finish here. You will have 2 assignments this week, and one is going to be about these 4 synthetic fibers. So make sure you complete them. I will see you in our next class.